Now let's continue on the next page. Talking of page 58. On page 58, the solution to the question. Express in degree, minutes, and seconds the C part of that question, and the D part evaluate the following ones: sine 2 pi over 3, 2, tan 5 pi over 12. And the solution for 60 degree, you have 60 degree times pi over 180 degree, and that gives pi over 3. For 270 degree, you have 270 times pi over 180, and that's 3 pi over 2. For 554 degree, that's 54 times pi over 180 degree, which is 3 pi over 10. Now, C, 24 degree, 4392 degree, 24.4392 degree, 24 plus 0.4932 times 60 degree. We want to take it to minutes. That's 24 degree, 29.592 minutes. Now, if you take that, the same thing as 24 degree, 29 minutes plus the decimal point, you multiply by 2 by 60. I have 0.592 times 60 degree, which is 24 degree, 29 minutes, 36 seconds. Now, we want to take the second part. The second part, that is arc sine 0.42 C2, 24.8346. Arc sine 0.42. To express that in degree, minutes, and seconds, so arc sine 0.42 is something as 24.8346 degree. We take the whole part, 24 degree, plus the decimal point, 0.38346, multiplied by 60, which is 24.50.076 minutes. We want to take that to seconds. The decimal point, 0.076 multiplied by 60, that gives 24 degree, 50 minutes, 5 seconds. The same thing with sine 2 pi over 3. That 2 pi over 3 can be written in degree as pi 180, 2 pi, 2 times 180 over 3. That gives sine 120. And sine 120 degree is root 3 over 2. The same thing with tan 5 pi over 12. Pi there is 180. 5 times 180 over 12, that gives tan 75. Tan 75 can be written as tan 45 plus 30 degree, and that gives tan 45 plus tan 30 degree divided by 1 minus tan 45 tan 30 degree, and that gives 1 plus root 3 divided by 1 minus 1 over root 3. Tan 45 is 1, tan 30 degree is 1 over root 3. So if you simplify that, we have on the next page the final answer there to give 2 plus root 3. Question 2. Find the arc length and the area of sector of the following circles. A circle of radius 7 cm and suspended angle is 45 degree. B, a circle of radius 14 cm and suspended angle is 30 degree. The radius, this A part of that solution, the radius is 7, the angle is 45. So if you express that 45 degree in terms of radian is 45 degree times pi over 180, which is pi over 4, and of course pi is 22 over 7. Now substituting length of arc is theta r, which is, and of course our r is 7. Our theta in terms of radian is pi over 4, so that gives 7 pi over 4. Substituting for pi, 22 over 7, and that gives 5.5 centimeter. The area of sector, half LR, since we know our length of arc to be 5.5, so we just substitute half into 7 pi over 4. That's the length of arc, 7 pi over 4, multiplied by half times r, and that reduces to 19.25 centimeters square. The P part is similar to A. R theta is our L, pi over 6, which is 30 degree. Our radius is 14. If you simplify that, you have 22 over 3 centimeter. The area of sector is half LR, which is half, and of course our L is in terms of pi, 7 pi over 3 multiplied by the radius, which is 14, and that reduces to 154 over 3 centimeter square. The question 3. If the area of a sector is 1800 centimeter square and its radius is 20 centimeter, find the angle of the sector and the length of its arc. We are given the area of sector, which is 18,000, and L, we don't know. We are looking for the length of arc and area of sector. So that's R is 20 centimeter, 20 times L over 2. If you simplify that, L gives 1800 centimeter, 1800 centimeter. Also, length of arc is theta R. We know the length of arc to be 1800, which is 20 times theta R is 20. So if you simplify that, our theta is 90 radian. Take note, your theta is in radian, not degree. So if you convert that to degree, theta will be 90 times 180 over pi. If you want to take from radian to degree, you multiply by 180 divided by pi. So 90 times 180 over pi gives 34200 over pi degree. So now let's look at the next page. Given that the square of the radius of a circle is 22 centimeter and the length of the chord is 2 centimeter, what is the value of the angle the chord suspends at the center of the circle? The solution: R square, the square of the radius of a circle is 2 centimeter, R square is 2, and R, this implies that R is root 2, length of arc is 2R sin theta over 2. Length of the chord is 2 centimeter and length of chord is 2R sin theta over 2, which is 2. So simplifying, 2, which is length of chord, is 2 root 2 sin theta over 2. 2R, R is root 2, 2 times root 2 sin theta over 2, which is 2. That is the length of chord. So sin theta over 2 is 1 over root 2. Theta over 2 is arc sin 1 over root 2, which is 45. Theta will be 2 times 45, and that gives 90 degree, which is pi over 2 radian. Question 5. Find the area and perimeter of the minor segment of a circle of radius 7 centimeter and suspending angle 60 degree at the center. Now the solution. Here R is 7 and our theta is 60 degree, which is, that 60 can be converted to radian, which is 60 degree times pi over 180, which is pi over 3. The area of the minor segment is given as half R square into theta minus sin theta. That gives half our R is 7 square into pi. Our theta is pi over 3. Suspending an angle 60 degree at the center, our angle is 60 degree, which is pi over 3. So half 7 square into pi over 3 minus sin 60 degree. Of course, now if you simplify that, so that gives 49 over 2. We cannot use sin pi over 3. We have to use degree there for that sin theta. So that gives 49 over 2 into pi over 3 minus root 3 over 2. Sin 60 degrees, root 3 over 2. So that's the area of the minor segment. Now to find the chord, we also have to find the perimeter of the minor segment. The perimeter of the minor segment is given as the chord length plus arc length. And of course, the arc length is theta r. But the chord length is given by 2r sin theta over 2. The length of chord or chord length is given as 2r sine theta over 2, which is 2 multiplied by 7. This is what I'm explaining here. 2r sine theta over 2, which is 2 times 7 sine 60 over 2, which is 14 sine 30 degree, and that gives 14 sine 30 is half, which is 7 centimeter. And arc length is theta r, which is pi over 3 multiplied by 7, which is 7 pi over 3, which is 22 over 3 centimeter. Hence, the perimeter of the segment is chord length plus arc length, and chord length is calculated that to be 22 over 3 plus the arc length, which is 7. Arc length is 7, and that gives 43 over 3 centimeter. That gives 43 over 3 centimeter. So that's the explanation on area of sector. And let's look at another concept on the next page. That's identities of the inverse of trigonometric functions. We know that theta, if A is sine theta and B cos theta, C is tan theta. Of course, theta can be written as arc sine A for 2. B equals to cos theta, theta is cos inverse B, which is arc cos B, and theta equals to arc tan C. Some properties and identities. Arc sine x plus arc sine x is pi over 2. Arc cosec x plus sec arc sec x is pi over 2, and so on. For 3, we have arc tan x plus arc cot x is pi over 2. Arc tan x is arc cot 1 over x. Arc cot x, same thing as arc tan 1 over x, and so on. Arc cos x equals to arc sine 1 over x. Therefore, arc sec x is same thing as arc cos 1 over x. Now, on the next page, we have the following. 6. For the 6, I have the 6th part. Arc sine x is same thing as arc cos 1 over x, and arc cosec x is same thing as arc sine 1 over x. And the 7th, arc tan x plus arc tan y equal to arc tan x plus y over 1 minus xy. So we should know that the inverse arc sine x is not the same thing as 1 over sine x. So let's take some proof on this. Example 1, question 1. Question 1. Prove the following. Prove that arc sine x plus arc cos x is same thing as pi over 2. A. Arc sine x is same thing as x, which is sine A. X equals to sine A. And B equals to arc cos x. If we let B to be arc cos x, x is same thing as cos B. But we know that sine A is same thing as cos B. Sine A equals to cos B. Why? Because x equals to sine A and s equals to cos B. S equals to, if you look at this, s equals to sine A, and the same x equals to cos B. So this implies that sine A equals to cos B. But cos theta is the same thing as sine 90 minus theta. That's complementary angle. 90 is pi over 2. Now, sine A is sine pi over 2 minus B. This implies that A is same thing as pi over 2 minus B. If sine A is sine pi over 2 minus B, therefore A equals to pi over 2 minus B. And of course, if you take B to that side, A plus B is pi over 2. A plus B is pi over 2. A from the above, A is arc sine B, arc sine x, and B is arc cos x. So arc sine x plus arc cos x is pi over 2. That's what they asked us to show in that question 1. And in question 2, we have to prove that arc tan x plus arc tan y equals to arc tan x plus y over 1 minus xy. So we'll say let A be arc tan x, and this implies that x equals to tan A, and B equals to arctan y is tan b. Tan A plus tan B, we know it can be written as tan A plus tan B over 1 minus tan A tan B, which is x plus y over 1 minus xy, because our x is tan A and our B is our x is tan A and our y is tan B. So when you substitute tan A tan B, you have that. So for the other part, I have a plus b is arctan x plus y over 1 minus xy. So a is arctan x and b is arctan y. So this shows that arctan x plus arctan y is same thing as arctan x plus y over 1 minus xy. And to prove that 2 arctan x equals to arctan 2x over 1 minus x squared. So on letting x equals to y in the above, that is in this proof above, x equals to y in this place. So we have arctan x plus arctan x, and that gives the following: arctan x plus arctan x equals to arctan. Anywhere you see y in this, put x. So that gives x plus x over 1 minus x squared. This is what we are proving. We are proving this 2 arctan x is arctan 2x over 1 minus x, and of course 2 arctan x, because arctan x plus arctan x is 2 arctan x, and that gives arctan 2x over 1 minus x squared. And when you do that, then we have arctan 2x over 1 minus x squared is same thing as 2. Therefore 2 arctan x equals to arctan 2x over 1 minus x squared. That's the proof for this one. And for number 4, prove that arctan 2x over 1 minus x squared is arcsine 2x over 1 plus x squared. And of course, by the above problem, we have that 2 arctan x from the above, this one here, 2 arctan x equals to arctan 2x over 1 minus x squared. This implies that we only need to show that 2 arctan x is arcsine this. We only need to show that 2 arctan x, because arctan 2x over 1 minus x squared is 2 arctan x. 2 arctan x equals to this one. That's what we need to show. So, but note that sine 2a, note that sine 2a is same thing as 2 sine a cos a over 1. Sine 2a, this is what I'm saying. Sine 2a is same thing as 2 sine a cos a. If you divide by 1, it's still the same thing. But that one can be written as cos square a plus sine square a, which is the same thing as, if you divide through by cos square a, so you have 2 tan a over 1 plus tan square a. We'll make use of that. So a is arctan x. X is same thing as tan a, but sine 2a is 2 tan a over 1 plus tan square a, which is 2x over 1 plus x squared. So 2a is arcsine 2x over 1 plus x squared. Let's take that again. From this place, sine 2a is 2 tan a over 1 plus tan square a. Our tan a from here is x, so that's 2x over 1 plus x squared. Of course, if sine 2a is this, then 2a gives arcsine this one. But what is our a? Our a is arctan x. So 2 arctan x is this, and that's what it asks us to prove. Now let's look at number 5. Question 5. Prove that 2 arctan x equals to arc cos 1 minus x squared over 1 plus x squared. Of course, it's similar to this question 4. Now let's act this one, arctan x, to be a. X is the same thing as tan a, but cos 2a is 1 minus tan square a over 1 plus tan square a. How did they get this? We can use cos 2a to be cos square a minus sin square a. Cos 2a is same thing as cos square a minus sin square a. So if we divide through by cos square a, we have 1 minus sin square a over cos square a divided by 1 plus cos square a, 1 plus sin square a over cos square a, and that gives 1 minus tan square a divided by 1 plus tan square a. Let me go over it again. Cos 2a can be written as cos square a minus sin square a. Cos square a minus sin square a. And of course, we know that cos square a minus sin square a divided by 1. And that 1 is same thing as cos square plus sin square. So cos 2a can be written as cos square A minus sin square A divided by cos square A plus sin square A. So if you divide through by cos square A, I have 1 minus sin square A over cos square A divided by 1 plus sin square A over cos square A, and sin over cos is tan. So that's why we have 1 minus tan square A divided by 1 plus tan square A, which is 1 minus a square over 1 plus a square, because tan A is x. And on the next page, I have 2a equals to arc cos 1 minus x square 1 plus x square. If cos 2a is 1 minus x square over 1 plus x square, of course 2a will be that. If cos 2a is equals to 1 minus x square over 1 plus x square, therefore 2a will be arc cos that. Arc cos 1 minus x square over 1 plus x square. So, and that gives 2a is arc tan x. 2 arc tan x equals to arc cos 1 minus x square over 1 plus x square. Now, of course, the student can go through proof 6, show that or prove that arc cos x equals to arc tan 1 over x is similar to the one we did earlier on. All we need to do is say let a equals to, the proof for question 6 is prove that, let me go through that again. It has to prove that arc cot x equals to arc tan 1 over x is arc cot x equals to arc tan 1 over x. So if we let a to be arc cot x, then x is cot a, and cot a can be written as 1 over tan a. So tan a equals to 1 over x, and of course a is arc tan 1 over x. If tan a equals to 1 over x equals to 1 over tan a, therefore tan a is 1 over x. So a is arc tan 1 over x. Arc tan 1 over x is a. So, but we know that a is arc cot x. We say let a from this. We say let a be arc cot x, and we are given from here that a is arc tan 1 over x. So arc cot x, which is our a, is same thing as arc tan 1 over x. Of course, the student should prove this, evaluate cos into 2 arc tan 1 over 4 plus cot 23 over 7 minus 30 degree. Show or evaluate problem 7. The student should go through it, and the solution is like this. That's the solution. The final answer is root 6 plus root 2 over 4. So the student can go through that, and that's where we'll stop today.